Good morning. We proceed with the next part of the lecture. The concept of tri-state buffer, which we are going to discuss today, is a very key factor in entire digital electronics, which is further extended to develop integrated chips, which in turn are microcontroller, microprocessor, advanced CPUs, everything which is digital in the world today. Hardly we find analog processing now. Almost everything in the entire world is digital. Analog signal is converted, that will come in our further part. Analog signal is converted into digital signal, that is processed by a computer, and it is again converted back to analog signal. You might be knowing bass treble few years back. It was amplifiers, frequency gains to be adjusted. But now that entire thing is digital. So this entire digital electronics is based on the concepts of gate. Number one, gate is a fundamental what we can say feature. Using gates without feedback, we can prepare any combinational circuits. Using gates with feedback, we can prepare a sequential circuit. And in addition, if the entire digital electronics would be incomplete if in addition to gate, a concept of tri-state buffer is not neatly introduced. With very rapid advancement of technology, there is a major problem in imparting education. That is, we have to cover many things. But to understand those many things, some very basics are also needed, even though those detailed basics may not be required actually. Say for example now, there may not be any need to use, you might have learned Karnaugh map, K-map. That K-map now might not be required to be understood by everybody except those who are designers, because it is just like a ready-made thing. Just like now, even you might be aware that Mukesh Ambani told that I made my kids to mug up the tables. ज्याला आपण मराठी टेबल म्हणून करणारे पाढे म्हणतो, पाढे पाठ करणं, पाढे आले पाहिजेत. With calculator available everywhere now, everything is there in the smartphone. There may not be any need. Means few decades back, to have expertise in table was giving you an upper hand in instantaneous calculations. Now it is no longer. You might have learned, ask your parents, that nowadays the clock is in the mobile, but otherwise you were having wristwatch, conventional wristwatch using small hand and big hand, kate, or you may also be having table watch or wall clock. Small hand and big hand, lahan kata and motta kata. And to know, to understand what is the current timing based on positions of both clocks was considered to be a, what we can say, classifying parameter amongst kids who are said to be smart and non-smart. जसं literate illiterate, साक्षर निरक्षर, तसं घड्याळ कळणारे घड्याळ न कळणारे. But now you have everything directly digital clock. This technology may be obsolete. So this may be obsolete now. Therefore, when things are proceeding in a rapid manner, we have to get rid of obsolete technologies. Means teachers should not spend time on teaching something which is irrelevant only because they had spent time in learning that. I hope you get me. Those who are hailing from Jammu and Kashmir can also understand such sentences. This is the conversion in mother tongue is just to emboss the meaning and not to explain the things. म्हणजे आपण हे शिकण्यात वेळ घालवला आहे हे माहीत असते, त्यामुळं ते आज उपयोगाचं नाही हे माहीत असून देखील मला हे शिकायचा त्रास झाला म्हणून मी तुम्हाला त्रास देणार असं शिक्षकांनी करू नये. सो टीचर शुड टीच ओनली दॅट थिंग which is relevant today irrespective of what they have learned or what was taught to them. But it is not that all old is obsolete. So some fundamentals, it means it is now very much delicate issue to decide what to tell in a lecture of say 1 hour, 2 hours, or say it is 2 hours per week, I will take some hours extra. Say, let us say that a 40-hour per course. The confusion in my mind is I am unable to choose what is required because I think that everything is required and therefore time is needed. You might be aware that Gandhiji has wrote a letter to his friend. It was a very long letter, and at the end of that letter he said, 8-page letter, that since I did not get sufficient time, I could not make the letter short. So I can go on talking as a freelancer, but if that is not optimum, it would be not fully, somewhat, I will not say wastage, somewhat non-effective utilization of your time. So I will try my level best to optimize what I tell. So unless, see, now Arduino is there even in some hobby class, may be administered to few high school students. So he understanding Arduino or civil, I will give a simple example. Even a KG going kid is able to handle the mobile phone, smartphone, which is Android OS based. So he is able to use that. So explaining using Android OS to a kid and explaining it to a computer science and engineering student, there is a vast difference. Like that, Arduino learned in a hobby class by high school student and Arduino taught in an engineering class. The treatment has to be essentially different. Therefore, I again repeat, these what I am teaching in this somewhat last lecture, this and next 2-3 lectures, that is entire digital circuitry base is on gate and tri-state buffer. Gate and tri-state buffer. Unless that is fully consolidated, the multi-storied building cannot be built. We have to use, when suppose if you are building a 100-story tower, in the base you have to put huge material. You have to ensure that it withstands. So that's what. So somebody may say, oh, what kind of material wastage is going on? So you should not look at it as a wastage. So in that aspect, the tri-state buffer is another device. So gates you might have learnt maybe in even high school. Now this concept of tri-state buffer I introduced, but today I will tell you gate and tri-state buffer in such a manner that you will not be able to forget even if you decide so. I again repeat. In Walchand College we have a very efficient system of training and placement where it is difficult for a student to remain non-placed even if he tries to attempt for remaining non-placed. So we proudly say that we place the students despite their desire, like that. The only requirement now is you should listen what I say. If you don't listen, then I do not have any Reiki technology by which I can impart on you. But once you listen, it is a reflexes. I'm very stressfully stating that the wording of these sentences while explaining these themes is arranged in such a manner that it makes an impact even if you don't want to have an impact. And when once you listen, it's forever, you can't unlearn that. You may be knowing tattoo किंवा आपल्या जुन्या याच्यामध्ये गोंधणे माहीत असेल तुम्हाला. एकदा गोंधल्यानंतर प्लॅस्टिक सर्जरी केल्याशिवाय ते निघत नाही. तसं मी जे आत्ता काही सांगणार आहे ते फक्त ऐकायचं आहे. एकदा ते ऐकलं की तुम्ही किती जरी म्हणलं की मी काही लक्ष देणार नाही, तुम्हाला ते आपोआपच कळेल. सो हिअर वी आर हॅव्हिंग an efficient technique to make the students understand despite their desire, even if they are not willing to. So I will explain very clearly some very fundamentals which you are aware now. A power. Now what is voltage? Again, see, this is the problem. This is the problem which I encounter when I start explaining something, that I use the word 5 volts. But what is voltage? This itself is a big question, not so easy to be answered. But right now, if I decide to divert there, then we will be going into an infinite loop. Therefore, I decide not to divert. Let us say that plus 5 volts and ground, it is a DC supply available to us. A DC voltage is available to us, is one assumption. So it is so simple, I repeat. And once this foundation is strong, you can go on increasing the stories to any level. So plus all everything in digital circuit is based on every digital chip. It is a gate and a tri-state buffer. Always it is driven by a supply voltage and a ground. A 5 volt DC voltage supply is available. Now, one more thing I will tell, you might be aware also, that light emitting diode, LED, light emitting diode. Now earlier, the diode was required to have those who have learned vocational 12th, a 330 ohm resistor was required. But now that 330 ohm resistor is inbuilt in the diode. So an LED having anode and cathode, when that LED glows, see this, I am explaining it into such a manner that everything should be understood even by middle school scholarship level student. I am explaining it in such a simple manner that a middle school scholarship student should understand. Anode and cathode. When the anode is at plus 5 volt and cathode is at ground, the LED glows. When LED glows, anode is required to be at plus 5 volts, cathode is required to be at ground, LED glows. So anode plus 5, cathode ground, LED glows. Anode plus 5, it is, so you may say that if your parents are educated parents, then don't tell that such thing was told to you in the class, because they might see that they might not be knowing the background in which we are discussing these things, and they will say that we will complain the authorities for such too simple, what we can say, kg going things. Anode plus 5 volts, cathode plus 5 volts, LED doesn't glow. Anode ground, cathode plus 5 volts, LED doesn't glow. Cathode ground, anode hanging, this is most important. LED doesn't glow, LED doesn't glow. Anode hanging, LED doesn't glow. Anode plus 5 volts, cathode hanging, LED doesn't glow. I hope the idea is very clear. LED glows if and only if plus 5 volts is there at the anode, that pin is logic high, and ground is at the cathode, that pin is logic low, then only LED glows. In all other situations, LED does not glow. In all other situations, LED does not glow. I hope it is quite clear. Number one. Now, with this, I will explain to you how a logic gate works. So once this base is very clear, I am confident enough that you will be able to understand all advanced things in this, what we can say, Arduino microprocessor, digital electronics, especially for electrical engineering students, even for non-electrical engineering students also, they will be able to get some good hand. Since it is a recorded version, even if I rub it out, you can go back and again see what you want. Now, what is a gate? What is a gate? Gate, how? Now, a question is asked to you that you have to teach a kid what is logic gate. How will you tell? How a logic gate works? To explain working of anything in the world to anybody is to make the person in front of you to be the device which is to be explained. You might be knowing a proverb, to understand my feelings you must be in my shoes. जगातली कुठलीही गोष्ट एखाद्याला समजावून सांगायची असेल तर ती कशी काम करते हे सांगायकरता त्या माणसाला सांगायचं की तू इथं असं आहेस आणि असं झालं की तू असं करतोस. So we explain that an individual what gate does is described by gate is a non-living entity. It's not now with the COVID virus, bacteria, living, non-living and boundary things are very crucial. But let us leave that aside. So logic gate is a non-living entity. Right? It's happening automatically. To explain logic gate, when I can understand the things best, if I have to work as a logic gate, how I will work? Then instead of you put somebody else, and instead of somebody else who is living servant, you put a non-living servant. So if I am able to codify the actions which I am supposed to take in a sequential number of steps, everything would be very clearly understood. So I will explain to you what is an OR gate. What is an OR gate? Obvious, I will make it big because I presume that you are there inside the gate. You are there inside the gate. Obviously, there are always two pins for any digital circuit, a supply and ground. What is voltage? I do not go into the details, and I presume that whatever pseudo understanding you are carrying about the concept of electrical voltage is enough for us at this stage, right? So a logic gate, which is an OR gate, is having two pins A and B. Is having two pins A and B, and an output pin Y, and an output pin Y. Now, what you are supposed to do, what gate does, based on the input state of A and B, based on input state of A and B, it is having some kind of logical operation, and it decides what should be the state of the output Y. So at the output Y, there is one pole two-way switch, one connected to plus VCC, other way connected to ground, and this is a switch. Who will operate this switch? Obviously you, because what I have told, that it is you who are watching the things. Who is means you are the gate. How you will operate the switch? Using hands. And how you will sense the inputs? Using eyes. So using this hand, you will operate the switch. Using your eyes, you are supposed to look at A and B. You are supposed to look at A and B. So let us make it gender neutral, otherwise, okay. So what you do, what is gate? Gate is a person like you inside this big box. In 1930s, computers were of the size of a room, multiple rooms rather. So you are there, you watch at the gate, inputs. So at the input, what is put? At the input, an LED is put. An LED is put. Now, here also, right? I will not go into the details right now, we will go at a later stage. An LED is put like this, and an LED is put like this. So this is LED A, this is LED B, this is LED A, this is LED B. Now, what you do? To be a servant in some scenario is a very easy job. Just do what is said to you, don't take any unnecessary stress. Watch at two LEDs. If any one of the LEDs is glowing, put the switch to position 1. Or else, if none of the LED is glowing, If any one of the LED is glowing, put the switch at position 1. If none of the LEDs is glowing, put the switch at position 2. And after that, what? When you are in 12th, solve CET paper, right? And when you have solved the CET paper, what is to be done again? Again solve the CET paper. So, I think you understood what I meant to say. Look at both LEDs using your both eyes, whether you are going to look with one on one eye and other on other eye is a different funny game. But look at both LEDs, and if any one of the LEDs is glowing, put the switch at position 1, else put the switch at position 2. And again go back looking at the LEDs. This is what the logic gate works. This is the manner in which the logic gate works. Logic gate is working with this logic. I hope it is quite simple to understand. Now we move ahead. After logic gate, the next very important part which I would like to teach is a tri-state buffer. Input A, output Y. Obviously this is always there, plus 5 volt and ground. A switch is here. Obviously, an LED is required. This is LED A. Obviously, again you are here. And a small change here, position 1, position 2, and there is one more position, position 3. So this is replaced as a 1-pole 3-way switch. The output switch is replaced as 1-pole 3-way switch. And there is, so what is this buffer? This buffer is will either produce the input A at the output, or will keep the output hanging. This tri-state buffer will produce either the input A at the output as it is, or it will keep the output hanging. It will keep the output hanging. Very important revolutionary concept. Then on what it can, what is input? Input is A. So it will either keep input at the output or keep the output hanging. If it is to keep input at the output, if this A is glowing, it will put at 1. If this A is not glowing, it will put at 2. And if it wants to keep it hanging, then irrespective of the input A, it will keep this switch at position 3. And when it will do that? For that purpose, there is an input enable. There is an input enable. Very important input enable. There is one more LED connected from this to this. This LED is EN. Now listen very carefully. Once this concept of gate is understood, then I repeat all entire digital electronics, all the chips, all the combinational and sequential circuits you can design using gates. Everything is combination of gates, just like we say that human body is comprised of basic cells. just like human body is comprised of basic cells, similarly a digital circuit is comprised of logic gates. Then and, or, nor, not, then universal gate. That discussion right now we don't do. But that is incomplete except when you add this. So if buffer is not understood, if tri-state buffer is not understood, then digital electronic study will not be complete. The digital electronic study includes microprocessors, microcontrollers, advanced CPUs, everything. So this is very important. Then everybody must know how this buffer works. In the buffer, you are there, you are looking at these both. So like you look here, like you look here, you look at this LED, you look at this LED. What is output Y? A truth table. A truth table is to be prepared. A very simple truth table. A new concept is being introduced in this truth table. Enable is an overriding input. Enable is an higher priority input. Enable is an overriding input. Enable is a higher priority input. You will look at the enable input if and only if, you will look at the other input A if and only if this enable is 1. So, if this enable is, so there are 4 combinations in digital electronics: 0, 0, 0, 1, 1, 0 and 1. If enable is 1, if this LED is glowing, then only you take what we can say pains to look at this LED. If this LED is not glowing, suppose if examination is there tomorrow, you will study. It is told that examination is not there. You will not bother what was to be studied. And you hang yourself. I hope hanging, you are aware of the exact meaning. So you look at this enable input. If this enable input is 1, if this LED is glowing, then you look at LED A. If that is glowing, you switch to position 1. If that is not glowing, you switch to position 2. So the output will follow input if and only if the enable input is 1. But if that enable input is 0, that LED is not glowing, exam cancelled, you disperse. So if that enable LED is not glowing, then you do not even take pains to look at input A or LED A. The moment at which you find that enable LED is off, irrespective of input A, you put the switch to position 3. And when you put the switch to position 3, output is neither plus 5 volts nor 0 volts, it is hanging, and that is called as a separate state called as Z. Hanging state. I will explain to you in very much detail what is the significance of this hanging state and all those things. So this truth table you can compress very easily in a simple short truth table, En and Y. If this En is 1, Y is A, and if this En is 0, irrespective of anything, this is twice set. So a buffer is a device which takes input at the output if that buffer is enabled, and if that buffer is not enabled, it blocks the input and keeps the output hanging. So to keep the output hanging is a special case, and therefore gate and buffer, you can't construct buffer using gates. Buffer is a separate device. Which you have to learn separately. Other circuits, multiplexer, demultiplexer, counter, shift registers, flip-flops, all you can design using gates. But buffer you can't design using gates, because buffer is completely an independent entity. The buffer is extremely important in learning. We will go into the details in the next part immediately. Thank you.